Okay, this is for the math refresher and specifically for pretest number 1, questions number 8 and 9. We've been getting quite a few questions about these two questions, so we thought we'd run a little video for you to show you how you might do these. And this question number 8 is a quadratic equation. And factoring quadratic equations is the stuff of the high school um, realm, and factoring quadratic expressions, as we have here, is the stuff of the high school realm. And we're going to show you a little method that will make this a little more mechanical, called the AC method, or you may have heard it called the split the middle method. It it's so named AC for the coefficients of the square term being the A value and the constant term being the C value. And so AC method refers to multiplying A and C. And so that's the first step of this method. And if you multiply um, 3 times 2, and notice I'm disregarding the fact that the C is actually a negative 2, I get 6. Okay. Then from there, I want to identify all factors of AC. Okay. So you identify all factors of that product. And so, of course, 1 and 6, 1 and whatever that product is, and in this case, 2 and 3. And then the next thing you want to do is you compare them, you compare to B. All right. Now, for this particular expression, the B value is a 1. It's right here. Right? And so looking at these pairs, I'm going to utilize the 2 and the 3, because if I do the difference between 2 and 3, I can get a 1. And more specifically, and more to the point, if I use a plus 3x and a minus 2x, I will obtain the 1x, which is the bx term. And so this is where you might hear it called split the middle, or why you might hear it called split the middle. So I'm going to rewrite, I'm going to explode this middle term, and instead of writing it as 2x, I'm going to fashion it as plus 3x and minus 2x. Now, from there, I will, so I'll rewrite expanding, I'll say, maybe a good way to put it, bx. And finally, I'm going to factor by grouping. Okay? Factor by grouping. So, factoring by grouping, we mentioned that in the introductory video on factoring. And all we do is pairwise look at these. So we're looking at the 3x squared plus 3x and the minus 2x minus 2. I'm going to factor each one of those pairs. The first pair, pretty obviously, both multiples of 3 and both multiples of x. So we factor those things out. And that leaves us with an x plus 1. And again, that's obtained by taking 3x squared and dividing it by 3x, being left with just an x, taking 3x and dividing it by 3x, and that gives us a 1. Remember, when you're factoring, you're dividing. Now, next, we have a minus 2x minus 2, so they're both negative. I'll factor out that negative, and obviously both multiples of 2, so I factor out the minus 2. And when you divide each of those terms by a minus 2, I think it's pretty clear that we're going to get an x plus 1. Right? Now, from there, you notice after doing both of those pairs, we have a common element to both of them. They share an x plus 1. So we're going to factor out that x plus 1. And when you factor out that x plus 1, that leaves you the first term with just a 3x. And the second term, you just have a minus 2. And so there is your factorization. All right. Now, we did still have a few students who weren't stopping here. We had a few students who set each one of these factors equal to 0 as if they were solving an equation. This is just an expression, and you're factoring an expression. So you're done right here. Um, you could, of course, write it as 3x minus 2 times x plus 1. It doesn't matter which term is first. Either way, by commutativity, of course, is fine. But you don't want to split this and set each factor equal to 0 and solve. And we were seeing that in a number of cases. So um, be aware of that. The steps again to that AC method: multiply A and C, identify all factors of that AC product, compare those factors to the B value, rewrite the expression expanding the B value, utilizing the selected factors. And then finally, factor by grouping. All right, so that's the AC method. Now, we also want to take a look, and we've had a few questions about number 9. All right, so question 9 is up here. And if you tried things like the AC method, well, number one, the AC method isn't going to work because the AC method is made specifically for quadratics. But if you tried factoring by grouping or anything like that, it isn't going to work. Okay. Now, there are whole courses taught in number theory and in factoring. It's a big part of encryption engineering and computer science and whatnot. Um, our point here isn't to teach a whole course in number theory, but if you look at the coefficients of this, and if your numeracy kicks in, you can sort of see how if x was a 1, right? If x was a 1, if I replace each occurrence of x by 1, and then do my arithmetic, I get 1 minus 2 minus 5 plus 6, which is 7 minus 7, which is 0. Which tells me I've just found a root. If this thing were an equation, I've just found a root, or what we call a 0, of the expression. Okay? In other words, if you were to graph this thing, on the in R2 on the Cartesian coordinate, it would cut through at x equals 1. It would go through your graph at x equals 1. Now, how is that pertinent? Well, if x equals 1 is a root, all right? If x equals 1 is a 0, then x minus 1, right? Bring the 1 to the other side of the equation here. X minus 1 would have to be a factor, all right? So, long story short here, what I've done is to discover a factor of the expression that I have. So I'm just going to get rid of this work. And again, this isn't really an equation. This is just an expression. But what I've just learned is x minus 1 would be a factor of this thing. All right. Now, if x minus 1 is a factor of this thing, then a couple things are immediately obvious. This term, this second term, you could start with an x squared. Because if we're going to have an x cubed, when we factor this, when we divide out an x minus 1, then there'd have to be an x squared in this position in order to obtain that x cubed. Now, also, and equally obvious, I'm going to say the last term of this expression is going to have to be a minus 6. Now, can you see why I know that would have to be a minus 6? Because minus 1 times minus 6 would give me the plus 6 I'm looking for in this expression. So we have the first term and the last term that we're looking for, but we've also caused some other terms. Namely, we cause a minus 6x when that product is done. And of course, we want minus 5x. So that tells me that this missing term in the middle, I am going to want to be a minus x. All right. So when I do that outer pair, I'm going to have a minus 6x. When I do this second term and middle term of the second factor, it's going to give me a plus 1x. And of course, minus 6x plus 1x is 5x. So I've got the the minus 5x, I've got the third term I'm looking for. Now, the question is, do I end up with a minus 2x squared? Well, if you take a look here, if you take a look at what's going to happen in terms of x squared, of course, this last pairing right here with the first term in the second factor gives me a minus x squared. And then when I do this x times this minus x, it gives me a another minus x squared. And minus x squared is the desired minus 2x squared. So I've sort of intuitively factored it. Now there are other ways. Once you discover this this first factor, you can use something called synthetic division that you may or may not have heard of. Okay. Again, the purpose here of the refresher isn't to go into a whole course in number theory or in the fundamental theorem of arithmetic or Descartes' signs. But there are other techniques once you identify that first factor. Now, we're not done at this point. That second term is going to factor further. And I think that's fairly obvious. It's going to be an x and an x. And you're going to want a minus 3 and a plus 2 to get that last pair factored. And so there, except for maybe the order, is your full factorization of the original given polynomial. So that's question number 9. Been getting a few questions on that. If you need more explanation on that, get back to us, let us know. We'll try to help you out.